We are in a discussion of AWS Solutions Architect, and we've been discussing about Elastic Container Service, which is provided by AWS. In my previous video, we're going to continue from our last video wherever we stopped. Today, we're going to discuss more further about ECS, but as I told you in my previous video, can you just compare EKS, Elastic Kubernetes Services, which is I'm going to discuss in a separate video, EKS, but as we're going to compare Dockers and containers and then Kubernetes services, I'm just going to have a touch base with this one. So Docker containers plus AWS EKS. So perfect partnership for container orchestration. So we already know orchestration manage containers. So that is what they does. So Amazon Elastic Kubernetes Services is a fully managed platform for running Kubernetes clusters, right? Kubernetes. So Kubernetes clusters in AWS clouds. We run them in as a bunch. So EKS orchestrate Docker contain at scale, handling the complexity of cluster management while you focus on your application. So EKS is an advanced way of handling these uh, Docker containers, right? And that is for like a microservices, right? It's a more complex than ECS container service. So um, you can see here, just like how do you manage in EKS? So we normally call the type of ones called pods, right? And they are normally in a micro services architecture. So you can see in the Docker images, right? Docker images, normally we're going to talk about container registry. So container registry where we keep our Docker images, and then AWS services and EKS cluster. So under cluster, how we deploying these Docker images through a container registry, and then EKS cluster does whole load balancing, auto scaling, and then these ones manage all worker nodes. So you can see while pod 1 and pod 2 are running the application, the pod 3 is running a database container. So that is just a touch base with the Kubernetes services. So this is a more advanced of ECS. So auto scaling container workload based on demand, the same one, orchestration, the automated deployment, so simplified rolling update and scaling operations. And then they are normally integrate with so many services inside AWS like IAM, VPC, and load balancers. And remember, we've been talking about storages also, EFS and EBS. So those are connected with them, and then you can see built-in encryption, network policies, RBAC, right? Rollback policies, not rollback, RBAC, right? Microservices architecture, deploy and manage distributed applications. So that's deploying and then CI/CD pipelines, automated testing and deployment workflows for developers. And then you have a hybrid cloud seamless workload portability across the environment. So that is a little bit of touch of EKS. All right, so we're going to back onto ECS, that is which we've been discussing. So let's talk about a few of deployment options. These deployment options include on the cloud, AWS cloud, and then you can do on-premises as well, right? See, in AWS cloud, as you can see in the picture, so you can use your AWS Fargate serverless containers, that option, and then you could use EC2 instance, so manage infrastructure, so you can control more if you use them, right? And then you could use on premises, which is what we call ECS anywhere, right? Local servers and virtual machines, right? So if you see what are the deployment benefits of cloud deployment is fully managed infrastructure, auto scaling capabilities with orchestration and pay as you use pricing, high availability. So they are the benefits if you deploy it in cloud. So uh, if you deploy it in on premises, so do you have a data compliance? You can have a data sovereignty control, and then existing infrastructure utilization. So you can use your existing utilizations, and low latency application is closer to you, and then compliance requirements. So if you have some data you can't put in a cloud, and you could use them in your own premises. So that is called ECS anywhere option, right? And see, you could see here before we going into this diagram, right? Let's see what are the options, more details on cloud deployment and on-premises deployment. So, cloud deployments, you can use AWS Fargate, that is the serverless. So you don't use your own EC2. So, or you can use only EC2 instances, right? So you can use orchestration, so automatic scaling, multiple availability zones, right? And a lot of services integration, right? ECR. So that is the Elastic Container Registry, EAM, and Elastic Load Balancing. So simplified management, right? So that is ideal for web applications, microservices, and cloud native workloads. While we looking into on-premises deployment, so that option is easy as anywhere. So that extend container orchestration to your data center. So register physical server. So VM to ECS clusters and consistent management experience across environments. So pricing uh, 0.01025 per hour per on-premises in instances, and alternative. So AWS Outpost for full AWS infrastructure on premises, right? So that is how you going to use them in a hybrid cloud architecture and a regulated workload. Right. So let's looking into bit of things in here. How do you looking as a so whole picture? So this area you can see AWS cloud, and then you can see here is your corporate data center, and so see that in here you have a GitLab repository. So repository which you control the coding and um, managing, applying, right? And then you have on-premises containers, right? And then you have a ECS agent in here to contact with the Amazon ECS, and then you have a system manager agent, and here you got a system manager system, talk to system manager, and here you could see ECS, right? And then you can pay deployment kit, right? CDK, and here in a region you have AWS account, and then you can use CloudFormation stack to deploy them, or you can use ECR, Elastic Container Registry, and then you have so many other options. So CI/CD pipelines like AWS Code Commit Service, and then code pipelines, and then code build, and then code deploy. So all these uh, pipelines you can use to manage, monitor, and configure these Amazon ECR. So this is a sort of a total picture. How can you manage Enimia? This is called AWS Enimia, and then this is EECS, right? So that is how your code deployment and on-premises deployment explained. So again, we already had a look at definition. So ECS is highly scalable container orchestration service, manage Docker, contain AWS infrastructure, right? So you have different types, and the different services, configuration. That slide came back again. All right. Okay, so let's looking into what is the ECS architecture and components. Actually, this Docker container service, what are the component as a whole service, right? So, so here you got a architecture picture, but let's have a look. So, what is the core component, right? So, clusters. What are the clusters? So, clusters are the logical grouping of compute resources. So, that is a compute resources, right? And then you have a task definition, a blueprint for containers. So, what does container instance have? So that has a task, right? What do you have? What this container is doing, right? And then you have a services, right? Services ensure desired task count, right? And then running instance or task definition. You have a task definition. So these services see that task container one, task container two. So the container instance one and container instance two. So application load balancer is running with services A and services B, which is controlling whatever each container need to be doing, right? So task definition is a blueprint of what is actually doing the task. So task definition is structure. So define container configurations, resource requirement, and networking setting for application. So it define what is the configuration. So what code is running in there, right? What sort of resource requirements? So how much memory, how much space required, right? So container image specifications, CPU and memory allocations, or network and security settings. So where does it connect? What IP addresses, right? And then what are the security settings? What sort of encryption, right? And those sort of things is under task definition structure. And then service management. So what services are running? ECS services maintain desired number of tasks and handle. So auto scaling based on metrics. So metrics, if any of them are, well, let's say GPU goes more over 75, that will generate add another one more container into the workload as cluster or load balancing integration and health monitoring and replacement, right? All right. So key features of so Amazon ECS, right? So what are the key features of this ECS, right? So the cluster management. So cluster management is simplifies managing group of EC2 instances that run containerized tasks without managing underlying infrastructure. So cluster management is a feature is a very important. It's a 95 important so compute resource management, right? It's one of the orchestration, right? And then you go to task and services. Execute and maintain desired count of task definition instance within an ECS cluster, automatically replacing tail task. So what we doing in there, like what is the processes we have to run in the as a task and services. So importance is about 90. And then you go to load balancing. So distribute incoming traffic across multiple containers to ensure high availability and fault tolerance. So make sure you're getting load is distributed balance in a balanced way that there's no any problem. So you providing high availability and fault tolerance, right? Again, then auto scaling, right? Auto scaling works for according to the load that's getting. So demanding workload, so auto scale getting more counts of containers, and then less workload, they cut off number of containers back to normal. And then service discovery enable containers find and connect to each other using DNS name, simplifying application networking. So that will enable containers to find and connect each other to distribute load. So getting more containers that so you getting that into the workforce. And then when you were disabling, or when you were removing one of the containers, the distributed load that back into whatever the containers left in there. So it looks like that, right? So then we're going to talk a bit of a core component of Elastic Container Services. So what are the core components? Let's have a look at what are the core components, right? So this is ECS is a group of containers, right? And Docker. So the Docker is a um, cluster of Dockers we call Amazon ECS. So mainly, so it's a three part. So it's got a cluster of EC2 instance, right? And then you got a task definition, right? And then you have a services to run. So there you got a container images, and then you have a CPU and memory, and the networking. The task definition, you manage these things, and then in the cluster you have EC2 instance and infrastructure, how its building blocks are made of. And then in services, you have to run task management, auto replacement, and then load balancing when the load become high and less. So the task definition is a blueprint for your application that specifies container images, CPU and memory requirement, port mappings, and network configurations. It defines how your containerized application should run. That is the most important part. How your things working. The blueprint when you're creating a container image, new container. So all the details should coming into that container, all the libraries, CPU, memory requirement, port mappings, everything needed to be there. So that is the blueprint of your uh, container. So what should it have? And then it become a cluster, the infrastructure where your application runs typically consists of groups of EC2 instance that host your containerized task. Clusters provide the compute resources need to run your container. So that is the major part. So your task definition, and then how do you run it, and then the next one is the ECS services. Ensure a specified number of task definition instances are running and maintained with the cluster. That is load balancing and monitoring. So automatically replace failed task and integrate with load balancers to distribute traffic. So when you have more workload, so we get more instances, and then when you get a less workload, so you get remove some instances where not necessary, right? All right, so then we'll have a quick look about ECS anywhere. So which is hybrid cloud environments, right? Hybrid means you running some of part of your uh, ECS in your on-premises and the other part you're running in the cloud. So features, right? So description is extend ECS to on-premises environment, right? So details register local servers or VM with Amazon EC2 cluster. So you register these local machines with your ECS clusters, right? And then you have a price model, right? So how much you have to pay hour per instance, right? And then pre-tier. So how much you can run in pre-tier. So you have valid up to 6 months across all regions, right? And then billing period from registration to deregistration, right? Minimum billing of 1 minute per instance. So that's whatever you use, you pay, right? So hybrid cloud benefits. So easy as anywhere enables unified container orchestration across cloud and on-premises environment. This creates a consistent management experience for all containerized applications, regardless of where they run. Uh, Cost 100 on-premises instance, 50 hours is 51.25. So 100 on-premises instances, if you run 50 hours, that will cost $51 and 25 cents. So that's how you will, regardless of you run wherever, right? How much cost you. All right, so we got some pricing models and cost optimization. If you want to have a sort of cost, because it's going to be costing per hour as well as the charging for your memory, how much memory you are using. So launch type is Fargate, that is serverless. So for the first three is Fargate, Linux environment, right? You can given OS architecture, and then you could see how much is a vCPU cost per hour, right? And then how much memory cost per GB, and then they all target, right? And regardless of what is the on-premises, you have to pay a 0.01025 per instant per hour, right? Mhm. So easy to launch type, you only pay for underlying EC2 instances, EBS volumes, and other AWS resources. No additional charges for ECS itself. Optimize cost with reserve instances, spot instances for non-critical workload. So that is you paying for EC2 instances, and then your hard disk, and whatever the resources you need, whatever the charges for resources, like you can use reserved instance for cheaper price, like a spot instance for non-critical workload. That is if you use EC2 instance, but if you use Fargate, it's only for resources allocated to containers. So pricing based on VCP use and memory used per second with 1 minute minimum, right? Fargate is put for up to 70% savings on interruptible workload. So, like instance type, uh, that can be changed chronic to instant type. ECS Anemia on premises, there is a flat fee. Includes a pre-tier with 2,200 instance hours per month for up to 6 months. Billing start when an instance is registered and it stop when it's deregistered. So you can test this one as a 6 months before you are actually going to start in your production workload, right? All right. For advanced ECS capabilities, right? Hold for a second. Yeah. All right. I think this is thing for today. And we'll see you guys from next video. Until then, thank you very much.